So far we've looked at waves in deep water. So these results we've been talking about are for waves in deep water. What we mean by deep water is that the water is sufficiently deep that the waves are not interacting with the bottom at all. So in general, that means that the ocean depth needs to be much bigger than half a wavelength in order for this situation to hold. Okay, and so there's the results that we've been talking about for phase speed, group speed, dispersion relation, etc., and the different velocities and sea surface heights are all given in this table here for deep water. Now, if the water gets shallow enough, for example, the waves approach the coastline, then they start to interact with the ocean bottom, and this actually changes the fundamental dynamics of the waves. So the solutions, the actual structure of these waves, and both their velocity structure and their dispersion relations are changing. And so that puts us into this so-called transitional regime in the middle here, with these somewhat more complicated expressions for dispersion relation and wave structures. We're not going to go into these other regimes in any great detail, but it's just something to keep in mind that you do have these different regimes, and there's an even more extreme regime where the waves essentially become invariant over the depth of the ocean, and that's this other regime called the shallow water regime.